Solving equations that are quadratic in form, Part 1. Solve the equation by making an appropriate substitution. X to the fourth minus 53x squared plus 196 equals 0. Now, this equation is quadratic in form because the exponents decrease by multiples of 2. So our highest exponent was 4, and then it decreased to an exponent of 2, and then it decreased to no exponent on the x variable. That means that we can use substitution, and we want to substitute a variable so that we can write this equation in standard form as ax squared plus bx plus c equals 0. So in other words, I want a letter that is squared and then a single letter. So I'm going to let u equal the x squared. If I let u equal x squared, then that means that u squared would be x squared squared, which is x to the fourth. Since I have an x to the fourth and an x squared in my problem, those are good substitutions. So again, I'll replace the x to the fourth with a u squared. This becomes u squared minus 53, and then I'll replace the x squared with a u plus 196 equals 0. Now my polynomial is in quadratic form because my highest exponent is 2 and it's decreasing by 1. Now that I have it in this form, I can solve this by factoring. So I'll set up 2 parentheses and set them equal to 0. Since I don't have a coefficient in front of my squared term, I know that the first term in each set of parentheses will be u, because u times u is u squared. Next, I'm going to look at the constant term, which is 196, and I'll list the factors of 196. I have 1 times 196, 2 times 98, 4 times 49, 7 times 28, and 14 times 14. I want to choose a pair that when combined will give me the middle term of negative 53. If I choose 4 and 49, I can do negative 4 minus 49 to get me the negative 53. And this will work because a negative 4 times a negative 49 will give me that positive 196. So I'll place a minus 4 in one parenthesis and a minus 49 in the other. And we'll want to check this out by foiling it or multiplying the two sets to make sure that you get your quadratic equation of u squared minus 53u plus 196. Now that I've factored this, I can set each factor equal to 0. I have u minus 4 equals 0 and u minus 49 equals 0. And we'll solve for u. We'll add 4 to both sides, and we get u equals positive 4. Next, we'll add 49 to both sides, and we get u equals 49. Now I want to solve this equation for x, but right now I only solved it for u. So to solve for x, I'm going to substitute the u equals x squared again and then solve for x. So I'll replace u with an x squared, and that will equal 4. And then again, I'll replace u with x squared, and this one will equal 49. Now to isolate the x, I need to take the square root of both sides. Whenever you take the square root of a number, we need to put that plus minus sign next to the square root. On my first equation, I have x equals plus or minus the square root of 4. The square root of 4 is 2, so this becomes x equals plus or minus 2. For my second equation, I have x equals plus or minus the square root of 49. The square root of 49 is 7. So I have x equals plus or minus 7. I can rewrite this out individually as x equals negative 2, positive 2, negative 7, and positive 7. Those are my 4 solutions to the polynomial.